This one is Geometry, Semester 2. It's the 4th unit, Conditional Probability. It's abbreviated there, but it's the first lesson, Permutations Practice. It's a little hard to say. It's on creatormath.com or creatormath.weebly.com, and it's under the Geometry tab. So the instructions are: copy the following 1 through 14 problems 1 through 14 into your composition book on the correct pages according to the table of contents with the notes for those pages. And again, Creator Math or creatormath.weebly.com. This one I'm going to show you. Go back to the website, and just to go back, let's go to home. Here's creatormath.weebly.com. Make sure you're under the Geometry tab. You'll see the table of contents. Scroll past the vocabulary. Find the table of contents. We're in semester 2. We're past the trigonometry unit for this video. We're past special right triangles. We are in solids. We're past that. Let's see, conditional probability. So that matches up conditional probability. This one is permutations, and it goes on page 8182. Here's the notes. The reason I'm going to bring them up is because we sort of do statistics light, but statistics can get complicated really quickly. And you're definitely going to need these notes in your composition book on the correct pages, and then you're going to copy these problems in after it and solve them. They're really working to lead us through statistics in this early stages. So here's what they say. For the following, state if it is a permutation, which parentheses deals with position with repetition, a permutation position without repetition, or a combination. Here it is. The order of selected items matters, but there are no repeating items. They are totally softballing this for us, but you're not going to be able to figure it out without the notes. So let's go straight to the notes. What do they tell us? The order of selected items matters. So let's see here. So drawing a group at a single time, and we are concerned with order. So this one says order of selected items matters. So that could be a permutation without repetition, right? And then there's another one, permutation with repetition. This is drawing out a group. So we need these definitions. Drawing out a group at a single time, and we are concerned with order, and there are repeating items. So the question is, right here, look at this, no repeating items. So it's not a permutation with repetition. There's no repeating items apparently, right? So we're going to do permutation without repetition, right? This one right here. And they're really leading us down the path. They're basically telling us what the answer is, but these things are so complicated if you're brand new to statistics, and we're in a geometry class. This is a statistics introduction inside of geometry. So we're trying to keep it as light as possible and give ourselves as many hints as we can along the way. So let's do the next. For the following, state whether it's a permutation with repetition or a permutation without, okay? Or a combination. We may find one of those. So the order of selected items matters. So that's a permutation, right? And then it says, and there are repeated items. Well, we already went through and read the definition. If it's without repetition, right, that means there's no repeating items. So I'm drawing out a group at a single time, and we are concerned with order. This one says in the definition, permutation with repetition, drawing out a group at a single time, and we are concerned with order, and there are repeating items. So this is a permutation with repetition. Okay, let's keep going. And as you see the confluence of this, you may start to go, okay, the words mean a little bit more to me now. The following is, we want to know if it's a permutation with repetition, a permutation without repetition, or a combination. Something tells me we're going to get to the combination example here, right? So the order of selected items does not matter. So for permutations, we were concerned about order. See, we're concerned about order for this definition. We're concerned about order here for both permutations. So let's look at the definition of a combination. Simply drawing out a group of objects at a single time from a larger group. So we actually started with a more complicated definition. Now this one's a looser or more less restrictive definition. So this is a combination because the order of selected items does not matter. Combination. Repeat those words after me so you can get them in your mind. All right, so if the order of selected items matters, but items don't repeat, then it is a permutation without repetition. What's the formula used? So now they're telling us it's a permutation without repetition. Sorry. Let's jump back to the notes. And here's the example in the notes, right? And the reason I'm keeping notes is you're not memorizing this at all. You're just reading the notes, trying to go through the definitions and read them a little bit closer. This one says if 3 items are selected from a group of 8 unique items, how many permutations are possible? Here's the actual computation for a permutation, right? N is the number of items. P is our probability, and the R is the number of options, right? So here's how we write it. So there's 8 unique items, right? So the 8 goes out front in the end. Then we have a P3, and this is how you write it, 8P3, and this is how you calculate it. We use N, which is 8 in this case, 8 exclamation point. So this is going to be new for you. This is called a factorial, right? A factorial is where we take the number of items and multiply them by itself. So let's see, so first, let's go ahead and pick the right one. This one's the right one, straight off the notes. And then let's talk about n factorial here. Okay, let's see what they give us. And looking at the notes too, let's go over to vocabulary. Factorial right here. They used an example 4 factorial, which is an exclamation point. So if you've got 4, and it's exclamation point, which means factorial, that means 1 times 2 times 3 times 4. You multiply all those out and get a rather large number. 3 factorial would be 1 times 2 times 3. 6 factorial would be 1 times 2 times 3 times 4 times 5 times 6. Now there's a number on our calculator. When we do a calculation with that, we're not going to do it out ourselves. We're going to push the factorial button and it's going to do the calculation for us. If the order of selected items matters, okay, so order matters, I'm thinking permutation, right? And items repeat, so I'm thinking permutation with repetition. What is the formula used? Again, we're going to go straight back through our notes and just read it right here, a permutation with repetition. Come up here in the notes, and the example they give us is, how many permutations are there in the state name Mississippi, Mississippi, right? A classic example of using this situation. So 11 are the number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 factorial, if I can say it right. And then the formula goes repeat 1 factorial times repeat 2 factorial and repeat 3. So because there's 4 S's in this, 1, 2, 3, 4, you're going to have a 4 factorial here. Because there's 4 I's, 1, 2, 3, 4, we have another. And then because there's 2 P's, here they are here, 2 factorial. Those get multiplied by each other. Right now, they're just asking us to pick the formula for this situation, right? And again, they're going to map out these problems for us and keep them in a very specific order so they don't get too complicated at this level and stage in our development for statistics. So let's see what they got. If we are selecting a group of objects at a single time out of a larger group of objects and are not concerned with order, then we are dealing with a combination. So they're even taking us back through that definition we already answered. Another way to think of combinations are selecting a smaller group out of a larger group. What's the formula used? So we're looking at the notes. We're going to combination. Here it is right here. NCR equals n factorial over parentheses n minus r n parentheses factorial times r factorial. Right? So we're just going to select that for now. Let's go to the next. They're going to have us fill in some of these. What are the number of permutations of 8 objects taken 3 times? In other words, how many different orders can 3 items have when selected at a single time out of 8 total items? Hint, the formula for finding the number of permutations without repetition is NPR equals n factorial, where n objects are taken r at a time. Right? So they're really just sort of having us now deal with the formula and plug in the idea that the number of permutations of 8 objects, and it's 3 at a time. So the formula here is this one, NPR, so number 8 goes out front. The R is 3, so that goes behind the P. And then we literally fill in the formula where it is 8 factorial divided by 8 minus 3. 8 minus 3, parentheses, factorial here, which equals. And now, that might be, I don't know if I've worked with this calculator. Let's see if I can go back to calculator. There it is. Let's turn it sideways, because you're not going to find your factorial key here. And let's just see if we can plug in. Clear? So let's just plug in the one they're giving us, 8 factorial divided by 5 factorial. Let's go to second, because I don't see the factorial button here. There it is, x to the exclamation point. See it? So here's how it goes. Let's see if I can figure it out. 8 factorial, right here. There we go. And notice that. Notice how big a number it is. That's 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. It's 40,320 divided by 5 factorial. 5 factorial. Bing, 336. So they even did the calculation for us here, and we see we can get it on our calculator, right? Again, they're making everything easy for us. We do have to go through the process of trying to do it, though, to get this right. All right, given the word mom, M-O-M, the order matters, and the M's repeat. If the 3 letters M-O-M are selected from a larger group, it is a permutation without repetition. Technically, the M's could be reversed to provide 2 selection options, but reversing the M's does not matter because both produce the same effect. Therefore, we say that the M's can repeat up to 2 times. We use a special formula to deal with this special situation of a permutation with repetition. It's n factorial, we already looked this one up in the notes, over repeat factorial, repeat 1 factorial, repeat 2 factorial, repeat 3 factorial, etc. How many permutations exist in mom? So notice the formula, they're giving us a lot of help here, right? There's 3 letters, 1, 2, 3, so that goes in for n. So you got 3 factorial, and the formula says to divide it by the number of repeats. So the only thing that repeats in mom is the 2 m's. So you have 2 factorial here. So all we have is 3 factorial divided by 2 factorial. Again, they're giving us as simple as possible, and I thank them for it. All right? 3 factorial divided by 2 factorial. And trust me, if it's the first time you're seeing some of these things, you didn't know they existed. All right? 3. So do they give us this here? Because there are 3 letters in the word and 2 repeats M. All right, they didn't do. Here it is right here. There's the 3. But that's the answer to this one. All right. Remember on mine, they all show up on the first option. For yours, they're going to be randomly put into the options. How many permutations are there in the state of Mississippi? So same formula, right? We're doing the n on top, count the number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11 factorial over the options. There's 4 S's, 4 P's, and, no, 4 S's, 4 I's, and 2 P's. There we go. So 4 factorial times 4 factorial times 2. So let's do this one. This will be more fun on our calculator. They're giving us an increasingly challenging set of problems. Let's start with 11 factorial divided by, I'm going to do a parentheses because these occur in, on the bottom. It technically doesn't matter, but I like for my brain to see them separated. Can I see them right here? Yep, I can see them barely. 4 factorial, there it is, times, because that's what this dot means, right? Another 4 factorial for the 4 P's, times, for the 2, no, for the 4 I's, for the 2 P's, here we go, is 2 factorial. Parentheses. Right, so 34,650 options. Because there are 11 letters in the word, 4 repeats of S, 4 repeats of I, and 2 repeats of P. They're really mapping it out for us to help us explore the definitions. So there's not really trying to trick us or anything. They're just trying to explain all that they can for us. All right, let's do 10. If we are selecting a group of objects at a single time out of a larger group of objects, sounds like a combination, and are not concerned with the order, sounds exactly like a combination, then we are dealing with a combination. Hey, another way to think of combinations are that we are selecting a smaller group out of a larger group. What is the number of combinations of 3 objects taken from a group of 8? Hint, use the formula NCR equals n factorial over n minus r factorial. And we kind of mapped one of these out. I'm not sure why the answers are showing up over here, but okay. So here they're just plugging it in, and I think that's what I should do on this one. Just model it on the calculator. We're clearing this out. We're taking 8 factorial divided by parentheses 8 minus 3 parentheses right here. And that's all raised to a factorial. Notice the factorial goes right on the calculation here. And we're not doing anything separately. We're doing this all in one fell swoop. Times the formula. The formula says times 3 factorial. Times 3 factorial. Right? Eight factorial. 8 minus 3 factorial times 3 factorial would be 5 factorial. Yeah, I'm not sure I like that. I'll go back and check that for you guys too before we do it, all right? All right, let's look at 11. How do we say 5 exclamation point? Well, I appreciate them doing that. And how do we calculate its value? Oh, so they're taking us backwards in time. They might have given us this one first, but now they're just checking up to make sure we understand it. We say 5 factorial, right? And I say factorial sometimes. It's factorial, just to make sure I pronounce it right. And what is it? It's 5 times 4 times 3 times 2 times 1. Or you could do it the other way. 1 times 2 times 3 times 4 times 5. All right? Either way, it's going to produce 120. And the calculator, of course, will do it for us. We just take clear, 5 factorial, 120. And you could do it yourself, right? You could go 1 times 2 times 3 times 4 times 5, 120. That's what the calculator is doing for you. Thank goodness they gave us a button, right? Automation, we like it. Okay, 5 factorial is the answer here. 5 factorial divided by 3 factorial reduces to what? 5, 4. Well, why? Because you have 5 times 4 times 3 times 2 times 1 divided by 3 factorial, which is 3 times 2 times 1. So the 3's, the 2's, and the 1's disappear, and you're left with just 4 times 5, or, and I would like to have them have put 20 here, right? Interestingly enough, because 5 times 4. For the following state, if it is a permutation with repetition, a permutation without repetition, or a combination, we are choosing a smaller group from a larger group, and order is important with no repetition. So go back to the definitions in the notes. If order is important, it's a permutation, and they're telling us no repetition, then it's a permutation with no repetition. And sort of the big difference is if order matters, right, it's a permutation. If order doesn't, it's a combination, if you haven't noticed that so far. 14. For the following state, if it's a permutation with repetition, permutation without repetition, or a combination, we are choosing a smaller group from a larger group, and order is important, okay, and there is repetition. Well, if order is important, it's a permutation, and if there's repetition, it's going to be a permutation with repetition. All right, so you're tracking the unit lesson number. This name's very important right here. This is how you find it on creatormath.weebly.com or just creatormath.com if that works for you. And you're matching up geometry, semester 2, it's under the geometry tab on this website. This is unit 4, conditional probability, and lesson 1, permutations practice.